Okay, example 1. A particle P is moving in a plane. At time t seconds, its velocity v is given by v equals 3ti plus a half t squared j. When t is 0, the position vector of P with respect to the origin is 2i minus 3j. Find A, the position vector of P at time t seconds, and B, the acceleration of P when t is 3. Right, be careful with this question. I know it's tempting when it says position vector to maybe use what we learned last time, the formula that position vector R equals RO plus VT. But you can't use that because that can only be used when when velocity is constant. Okay, in this question the velocity is not constant because you've got a time in the velocity and we know it's accelerating, so the velocity is not constant. Oh my God, I can't spell today. Velocity not constant, so we can't use the position vector formula. Therefore, we need to use differentiating and integrating. So for part A, when it talks a position vector here, it's basically saying find R or S, whatever one you want to think of that as. Okay, so displacement. So I want to find the displacement, and I've been given V. Remember, it goes displacement to velocity to acceleration, doesn't it? Okay, so if I've got V, I want to go back to displacement. If I go this way I'm going to differentiate. This way, I'm going to integrate. So if I've got velocity and I want displacement, I have to integrate. So I take my velocity, which is this, and I'm going to integrate that to get the position vector. Now, position vector, we usually use the letter R rather than S. So we say R is the integral of velocity with respect to time. Okay, so to get R, we're going to integrate our velocity with respect to time. Okay, and then just integrate that like normal. So if I integrate that like normal, I'm going to end up with spatial. Increase the power. Ignore the I, just work on this little bit here. So increase the power of t. So that's 3t squared divided by the new power. Again, ignore the j, just focus on the t. So increase the power, divide by the new power. So a half divided by 3 is going to give you a sixth. So that's going to be t over 6j. Don't forget the plus c, that's the most important bit there. Okay, now we need to try and find this c. Now to be able to find the c, you need to go back up to the question, and in the question it should give you some information about the time at the beginning. So at the beginning, so when t is 0, it should give you some information. It does tell you the position vector is 2i minus 3j. So when t is 0, the position vector is 2i minus 3j. And I can use this information substituted into this to find c. So if I put this into this now, I get 2i minus 3j for r there. Where I see t, I'm going to put 0. So I get 0i plus 0j plus c. And you should be able to see then c equals 2i minus 3j. And then we just put it all together. So if that's c, put c back into this then to get your final answer. So r is 3t squared over 2i plus t cubed over 6j plus c, and c is now this, 2i minus 3j. And then it's a little bit nice to write it with all the i's together to make it a bit neater. So if I combine the i's, I get 3t squared over 2 plus 2i plus t cubed over 6 minus 3j. And that's my answer for part A, that's the position vector. Okay, part B, let's bring it down, says find the acceleration when t is 3. So if I want the acceleration, if you think actually back up, apologies, to this diagram, if I want acceleration and I've already got the velocity, to get from velocity to acceleration, I've got to differentiate. Okay, so I say that acceleration is differentiating velocity with respect to time. So if I'm going to differentiate this, if I differentiate this bit, I get 3i. If I differentiate in this, bring the 2 down, gives you 1t. J. Okay, so that's my expression for acceleration, and they want it when t is 3. So when t is 3, a equals 3i plus 3j. And you can put units in if you want there. Okay, and there's my answer for acceleration.